My name is Chase Fell. I'm chair of the ESA Technical Education Committee. I'd like to welcome you this morning to our technical seminar, Failure Modes, Troubleshooting, and Maintenance Best Practices for Field Service. I'd like to give a warm welcome to our presenters this morning from Shermco Industries, Ron Widdop and Calvin Earp. They'll be talking to us about real-life experiences in field service and testing and troubleshooting. There'll be opportunity for us to ask questions, I think. The bios of these two gentlemen are on your app and on the ESA site. I encourage you to take advantage of that. Also, there are no handouts, as you're aware. The handouts will also be available to you electronically, as well as I think a video of the presentation. So please welcome Ron and Calvin.
Well, thank you, Chase. Thank you, Chase. Let's see. Can you hear? Is that good? Perfect. Well, good morning, everybody. And yeah, we've got about just under an hour to talk about a little bit of field service things, and there's going to be a central theme that's going to play out through this because there's a lot of material kind of going in a lot of different directions in a short amount of time, and so what we really want to do today with all of you here is what I'd ask is that to get you to maybe think a little differently or think a little bit deeper about certain aspects of the business that come around each and every day. Like Chase said, I actually on D-Day, June the 6th, I started at Shermco in 1983, so I just hit 38 years with the company here about 3 weeks ago, and started out in the field and kind of worked my way up through the years through management and all that. And so when you're in the field, you see a lot and you do a lot and you build your experiences and all that. And there's a really good quote by Maya Angelou. If you don't know of her, she's a pretty famous civil rights activist and passed away now. And really neat lady. Do a little internet research on her. And there was a great interview I saw back. It was probably in the 80s that she did, and she talked about her hometown and all that. But anyway, neat lady. But she said she had this quote. She said, "Do the best you can until you know better, and then when you know better, do better." All right? She'll say, okay, so what does that mean? And so what it means, or what she was getting at is that, and for all aspects of life, but she says it means that people often make mistakes because they don't know the right way to do something, right? And then once they understand or they know better, well then they can change their actions and they can do better. And so you can apply that to troubleshooting of motors and electrical power systems or anything in life, right? But once you know better, you do better. And so if you take some time and you learn about your craft and you learn, you know better, you do better. And so I think that's kind of what we're trying to do here today, or what we hope to do is to maybe get you to think a little bit more, give you a little bit of exposure to some things, and try to let you know better so that you do better, whatever that might be. And today we're going to talk specifically about motor stuff, because Calvin's a field guy.
Motor stuff, yes, sir.
Motor stuff.
Yep. The safety and the practices as far as maintenance is concerned.
Yeah, and so I should say too. So Calvin and I actually were co-presenting. So I'm kind of taking the lead on this one, and then we're doing another session at 11, and he's taking the lead on that one. But if there's any questions at all, especially hard questions, Calvin's going to answer all of them, because that's why he's here. He'll say, "I don't know, ask Calvin." But no, once you know better, you do better. So when we talk about rotating machinery, everybody knows it's not your grandpa's business anymore, right? I mean, things have changed, but in the fact that things have changed, many things have stayed the same. I think there's a paper that you have to write in support of the presentation, and y'all will have access to that. And one of the things that, $10? Somebody's phone rang? No, sorry, just kidding. So one of the things that I noticed, I received from a library from the 1800s and electrical world, these old articles and all that stuff. And you look at an article it was in 1898, and there was a picture of a motor, and they talked about things that were going on in 1898. And you look at a picture of a motor today. Well, not a lot of things have changed a whole lot in many aspects to the way those things look. 746 watts per horsepower, still 746 watts per horsepower. But so the principles are the same, but the technology and all that obviously has changed very much. So the complexity in the impact is different today than it is or was, many years ago, and it continues to evolve. We just heard that this morning from Jerry's presentation, and we talk about industrial Internet of Things. That's going to embed itself into machines more and more as we go through life, and AI and robotics and all that. So we'll have to constantly know better and do better as we go through life, especially when it comes to determining what happened to a machine in the field, why did it happen, and what are we going to do about it. So when rotating machinery fails in the field, and they typically always do, unless you take them out before they hit the end of their service life, it's really important to understand how and why they failed and apply the correct, and we say this, the safest troubleshooting techniques, because oftentimes when you get in troubleshooting, you're gonna expose yourself to hazards in doing that. And then use best practices for maintenance and testing of those various tasks. And so again, we're going to talk about some of that stuff. So when we talk about motors, again, in 1898, it wasn't very complex. But today there's many varieties, many complexities of rotating machinery. And we've all probably seen these. And, there's going to be more and more of that. As electric vehicles get more and more prevalent, we're going to be doing more with that complicated stuff, right? Which can be very complicated. But there's some basic principles that are always there and always remain. But there's a lot of things that can happen and be there. And when we talk about energy use, as much as we'll see what the Green New Deals of tomorrow end up being and how much that has an impact to us. There's no doubt it's going to change the way we live and the way we operate, and distributed generation and solar and all that stuff, battery, all that stuff's going to change the power grid, no doubt. But about 40% of the electrical consumption is roughly around motors and motor-driven systems. I'm sorry, I got confused. I was looking at something else. Electricity accounts for 40% of the energy consumption in manufacturing, and of that, about 68% is motors. And it varies depending on who you look at and all that. But there's one thing that isn't going to change is if you've got a 10,000 horsepower motor that pumps water from a lake to a treatment plant, that motor is not going to get its power from batteries and solar power. It's going to take, some hefty power to keep that thing going. And we'll see where all that goes. But as that technology changes and evolves, again, when you know better, you do better. So we have to keep an eye on that. So first, how and why did a motor fail? So we're going to talk about why did it fail, how did it fail, and what are we doing about it. And there's a great amount of resources within ESA and the ESA organization for figuring that out. And one of those is the root cause failure analysis publication. If you don't have this, you should get that, download it, buy it. It's a great resource for just giving you a thought stream for what to do when a motor fails and what is that reason for failure. And I did a highlight here of it, looking at the root cause, and so there's a 5 why method that ESA has in there. And so if you look at that flow chart there, you can see there's some great guidance in that. Let me just go over here and I'll show you on what to do. So you had a machine, you're in the field, so your plant's down or whatever, and you go, well, what happened? And so when you look at this, you start right here, and it says, what's the problem characteristics? So ask yourself why. And say, do you think you know? And say, yes, I do know. And so I'm going to test that cause because I know what it is. And then, was it confirmed? Yes or no? So, okay, if it is yes, then, okay, what was the root cause? Do I know what the root cause was? Yes, I do. Well, guess what? You've just figured it out. And so now you have a lot of information, a lot of data. You've asked a lot of questions, and you've determined why that failed. And so now you can do corrective actions to keep that from happening again. So looking at it the other way, you ask yourself, well, why? You said, do you think you know? I said, well, I really don't know. And say, okay, well, what's the list of potential causes for that? I said, do you know, yes or no? I said, okay, well, here they are. I said, well, what's challenged those causes to see, are those really viable causes for failure? And then select the most likely one. And you test it. Test that cause. Did it confirm it? And you say, well, no, it really didn't. Okay, well, go back and look at one of the other causes. Test that one. Did it confirm it? Yes or no? And when you finally get to the point, yeah, that's really probably most likely the likely cause of failure, well, then you've confirmed it. You look at your root cause, and you look at, was that the root cause, yes or no? And if it is, well, then you're done. So, again, it's a pretty simple process, but it's one that asks you ask why, and if you ask why, instead of just assuming, never assume, you can really get to the source of a problem pretty quickly, and it happens in a structured way. And again, ESA has great insight and guidance for that. The other thing that there's been many studies and information about why motors fail, and EPRI and IEEE have put a lot of information out. And these are, generally speaking, about half the failures end up being bearing failures on machines. And I know that stators have about, it says 16%, and external sources 16%, unknown about 10%. We really don't know why it failed. And then we have rotor bar issues at about 5%. And so, again, these are general percentages, but there's things that you look at. There's categories of failures. Look at those. Use the ESA guidance and hone in on the root cause, the problem, and then ask yourself questions. And oftentimes this happens a lot where, especially if you say, okay, I had a motor fail, right? And so you're focused on motor fail. Why did it fail? Well, you have to step back too and look at all the conditions. There's many factors that can be involved in external factors instead of just the motor. Shermco started where I work as a motor shop in 1974, and as we grew the motor business, we found that people were calling us and say, "Hey, my motor failed. Can you come fix it?" And so we'd go out in the field, and we look at the motor and say, "Well, test the motor." Well, the motor's fine. It's not the motor. It's the switchgear or something else. And so that evolved. That led us and evolved to where we started our engineering services and our field services and all that. And so we started looking at switchgear and looking at power quality and all that. And so that was a natural kind of extension to what we do, and as many as I'm sure many of y'all do as well. But it's not always the motor. The motor may have failed, but it may be because of external factors that happen. There's a picture of Columbo here, and you always got to, he always, if you remember that show, he would always leave, and he'd leave and say, "Oh, just one more thing," and so he'd ask a few more questions, but yeah, I was thinking about something. And so do that. Be a Columbo out there. Ask a few more questions about what's going on around you. What's the environment? How's the power quality? Do you have mechanical systems that affect, has loading changed? Has your plant production changed? All those, again, it goes back to those whys. And again, from the ESA guidance, there's several external factors that could ultimately lead to the failure of a machine. So it's very important to step back and look at the situation from a more global standpoint, and especially if you're the guy that everybody's looking at, and management's around there and all that, it's good to just take a breath and step back and think about things, and because it may be something that you're not thinking about. So when you know better, you do better. And so now we've got to the point that we think we know what we're going to do, and we're going to apply some of these troubleshooting techniques and start to really dive into the problem of this failed machine, or this may not be a failed machine, or some issue, whatever it may happen to be. And so let's think about it differently. And I'll say this: so now when you get into looking at, so you're troubleshooting a drive problem, or you're troubleshooting some vibration issue, or whatever it may be, or even you're looking at it's not the motor, it's the switchgear. So you get into that. And so the first thing we have to say, and we always have to bring this to the forefront, is safety. because you got to be qualified, you got to understand the hazards, you got to be able to identify the risk and all that. So we always got to start. Really started thinking about safety and being a qualified worker for that task. NFPA 70E standard for electrical safety in the workplace. It applies to all of us in how we interact and deal with the hazard of electricity. It's a really, if you don't have the 70E, we talk about it later. You really should get it and understand it. But they have a definition in there of a qualified person. And so a qualified person is one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations, and has received safety training to identify the hazards and reduce the associated risk. And so that's really important. And it's really not that hard to have a qualified worker, because you don't have to be an electrician to be a qualified worker. You don't have to be, have 50 years or 20 years or 10 years of experience. You have to be qualified for the task you're about to do, that troubleshooting task you're about to do. And it really becomes apparent when you get into medium voltage, or important, more so, I would say, or as important, I say, in medium voltage systems. You don't want a guy or gal to walk up to a 2300 volt or a 4160 volt contactor to try to figure out why something won't start, and to take a wiggy or a fluke and put it across a fuse, a medium voltage fuse, to measure the voltage or see if it's open or whatever, and not understanding that is medium voltage equipment. Happens all the time. We see it all the time, where people apply the wrong rated meter to a system, and the meter blows up in their face, and it hurts or kills them. So that's part of being qualified, is you have to understand what the nominal voltages are and being able to identify that. And so don't put your people out in the field doing troubleshooting that don't understand those aspects of the business. And it's really important on 480 volt equipment as well. A 480 volt motor control center could do a lot of damage to you and equipment around you based upon the fault current and incident energy and all that. I was involved in a 400 amp 480 volt automatic transfer switch failure in 1984. Blew up in my face, put me in a hospital for a week and a half and off work for a month because I did something wrong. And it was just 480 volts. It's just 480 volts. It's not that big a deal. But it is a big deal. It's a big deal at 480 volts, at 240 volts, at 2300 volts, 4160, 13.8, whatever. The thing about the high voltage equipment is it usually gets a lot more attention from management and all that. And so well, that's high voltage, So we got a special team that does that. And we see this a lot, where it tends to not get quite the attention on the low voltage equipment because there's so much of it, and it's in the plant and people. But I'll tell you, man, that 480 volt stuff will get you pretty good as well. There's a lot of incident energy and heat that can be released from that. So just a point of clarification is make sure your workers are qualified. Very important, very important. And so why do we care about that? He said because electrical equipment is dangerous. There's a tremendous release of energy, or can be, with a fault. You can get burns and equipment damage and all that. And it can be very complex. Even the simplest thing can be a complex situation to the worker that he sees in the field, depending on what he's doing, right? And depending on what can happen with backfeeds or things getting turned on or not locked out properly, or transfer switches or transfer schemes that can close in on you. You have to understand all that before you troubleshoot and work on it. And for those of you that have been here, and I bet this is the same with everybody. So everybody I talk to that's an ESA shop, and we talk about business. How's business? How's it going? We just had a discussion up here not 10 minutes ago, and said, what's your number one problem? Everybody has the same number one problem. What's your number one problem? People, right? Can't get enough people. Can't get anybody that wants to work, or that that is qualified and all that. So everybody has the same problem. So there's a shortage of people, which then, again, goes back to that safety comment. So now you have to make sure that you're training those people, not putting them out there too quickly, not exposing them to hazards as employers and as managers and all that. It's our responsibility to make sure the people we put out in the field are qualified to do those tasks. And so, again, because it's always out there, it's always prevalent. The people are retiring. Education and training is key. And so understanding of maintenance is also key. There's some things I'll talk about in a minute in the standards that are driving us to understand that a little bit more about condition of maintenance and things like that. And so if we don't understand all that, then we really have some issues. So again, the more, when you know better, you do better. And the other thing that's also interesting is there's some troubleshooting on here going on. And that guy in the picture, hey, Kevin, look at this guy right here.
I saw that the other night. So that was about.
What are you doing there?
I was collecting vibration data on a 1,500 horsepower DC motor. This was taken back in probably the mid '90s. It was before we moved to the Pioneer location. But so when Ron talks about the electrical safety, so what I'm doing is I'm going to the bearings on this DC motor, and then it's got a jack shaft that goes to a wall. It's in a steel mill, and on the other side is a gearbox that drives a mill stand. So I was going through some of our presentations that we use at Shermco, and one of the presentations, it shows a guy, it looks like it was like a forced draft fan motor, and his lanyard got caught up in the coupling. The coupling didn't have a coupling cover on it, and wrapped him and the harness up into this coupling, and like his foot is up by his head. The guy was dead, right? So it's not all electrical, it's mechanical as well. And going out and being able to understand the things that you're doing out there. And so I was thinking, when I started at Shermco in 1990, and back then we worked in the shop. I was a mechanic, and if we had a field service call, we would, Homer Travis, who's our shop manager, he would come out and he said, "Hey, Calvin, I need you to go down to this pump station. They got a problem with this motor." So I had a toolbox I used in the shop, and I would think, okay, what do I got to bring, right? I would open up my drawers, make sure that I've got all the tools, and I'd take my tools out to my personal truck. Shermco paid me, I think, 29 cents a mile to drive my personal truck to the job site. But I would get out there, and back then we were not as well trained as we are now as far as the safety aspect, especially on the electrical side. So I get out to this pump station, and I go over and I'm like, okay, so we open up this breaker. Well, how do I know that this breaker's all the way open, right? Well, I go into the control room there at the pump station. It's got a dial phone, and I call up Homer and I say, "Hey, Homer, how do I test for the live voltage on this?" He said, "Well, do you have a tow chain in your truck?" I said, "Yes, sir." He said, "Well, open up the cabinet and throw that chain inside on the conductors, and if it doesn't flash over, it's not hot, right?" So we've come a long way. There's some things that we do. I used to have a hard hat that said "whatever it takes" on a sticker on there, and now whatever it takes as long as it's safe, right? So so that was probably 1995. The deal at the pump station was probably about 1991 or 1992. We've come a long way in safety. I think we're one of the leaders in the industry, and this is some of the message we're trying to get out to people, that, trying to find good help and having them understand what they're doing out in the field, not only in the field but in the shop as well.
Yep. Once you understand, you can change your actions. When the transfer switch blew up on me in 1983, I wouldn't do today what I did back then because I know better, right? It's just the way it goes. But when you look at your approach to a situation, here again, it's one of those things that whatever it takes, like Calvin said, right? So you're trying to figure out. Well, sometimes this happens in disaster. We do disaster recovery work. Everybody's do a flood or something like that, right? And when you do a disaster recovery project, especially a large scale project, we always like to say we want to be on the boat. So when the flood waters recede, whether it's a hurricane or a stormwater surge or a river flood or whatever, and plants underwater and everybody's running around crazy and all that stuff, the decisions you make in those first few hours can have tremendous impact on the back end on the recovery efforts, right? And so instead of just jumping in and getting everything out and ripping it out and trying to fix it, you got to step back and put some problem-solving skills to work, because it pays tremendous dividends on the back end. In a large way on disaster recovery, in a small way on a 3 o'clock in the morning failure in your plant. So if you apply some basic sort of approaches to that, and you focus on the solution, define the problem, agree on the process, and then be sure you use active listening. And there's some expansive stuff on that in the paper. But sounds very simple, but it's often not done because people want to get in and get the plant. The plant manager screaming at you and all that. And so sometimes you just got to step back and remain calm and just sort of go through the process. It can really be beneficial for the repair of that machine or that problem. And so there's a lot of questions, just typical questions, what kind of system protection is there? How often is it started? Are there idle periods? What's the last time service or maintenance happened? Has there been any changes? All these questions, you have all that stuff that you just got to ask yourself. Go through a logical step, go through a logical process. And then when you get to that point, so then the other thing, so now we're going to talk about kind of a third section here is using industry best practices to help us and give us some guidance. And I'll tell you, there's three very important things that we can do on rotating machinery, three very important things to think about as a resource, as a best practice. And if you want to write these down, it's ESA, ESA, and ESA. I mentioned it before, and not that it's self-serving for an ESA convention, but it's true. But ESA has tremendous resources available to all of us to use every day, 24 hours a day, whether it's technical resources on the website, the technical resources they have in St. Louis, the guidance they give us in documentation. If you're not up to speed on all that, I mean, really, I can't tell you enough how much you should do that. And so there's many resources and guidance for that. We're going to talk about a few of them here. Some of them you may know about, some of them you may not. Some of them you may not be thinking about in that way. And so these resources, if you use these in your day-to-day operations with your customers, with your people, and all that, it'll really help you. And again, I mentioned ESA because that's who we are. And AR100 is a great document for understanding repair and maintenance and troubleshooting of machines. It's a lot of it, most of it's for the shop work and all that, but if you take the AR100 and just kind of understand that and apply those things into the field, there's field information in there as well. It can really help you out quite a bit. And so you say, well, I don't know. I haven't really read that. It's a standard, and so it's an ANSI standard, so it has to be written in certain language type. And so some of that's a little disjointed, and it's not how we talk normally. But if you take the time to read it and understand it, again, it'll help you a lot. One of the things you might try to do is in the workplace is everybody that works for you should have a copy of the AR100. If you don't, get them a copy. It's free. You can download it off the website. Put one in the break room, put one in the can, put one everywhere, and just read it. And then the other thing you might do is just for fun have a contest. Just go out in the shop one day and say, I got $20 Starbucks question. Anybody can answer this question, XYZ, from AR100, and kind of make a little competitive thing out of it. Do stuff like that. Get your people engaged in that, understanding kind of more about that standard in particular, and all these resources that we talk about. Because when you know better, you do better, right? Another one is the NETA maintenance standard. And say, well, NETA, well, that's in that switchgear stuff, and so we're involved with NETA. I've been involved in that association for quite a while. NETA is related to it's a trade association, much like ESA, but it's specifically for test technicians. But they have a standard called the NETA Maintenance Testing Standard. And so what that does is by device, it tells you what to do relative to test in the field for that piece of equipment, be it a power transformer or a cable or a relay, or an electric machine, electric motor. There's a synchronous machine and induction machine. And so the NETA testing standard is a great resource. Again, it doesn't tell you how to do it, it tells you what to do. And so if you look at that standard and you're saying, well, what should I do in my maintenance program to help me better understand, what's kind of the industry standard for that, check out the NETA standard because it's got good guidance there. I would say it does. So Section 7 of the standard has again, the particular type of equipment, and there's about 25 categories. Again, one of them is rotating machinery, and so it gives you visual mechanical inspections, what to do, gives you electrical tests, and then it gives you test values for visual mechanical, which some of those visual and mechanical tests will have an expected result. Some of them don't. And so the ones that do, they list the expected result. And then they have test values for electrical. So if you're doing an electrical test on a machine, there is an expected result. You wouldn't be doing a test if you didn't get an expected result. Now, some of it's just pass-fail. If you're testing something that just has a pass-fail criteria, that may be the criteria. But if you're doing other tests that have definitive results, there's going to be an expected result. Polarization index has a specific expected result, or dielectric absorption ratio has a specific result. Those results will also be in there. So you can do the electrical test. You can see the expected results on the electrical side. Great guidance for what to do in the field from a maintenance or an acceptance testing standpoint from that standard. Another standard, or it's actually a recommended practice that is about to be a standard, is NFPA 70B. So NFPA is recommended practice for electrical equipment maintenance. And so the NFPA 70B document is currently in a revision cycle to be rewritten as a standard. And you say, okay, what does that mean? And so what that means is, as a recommended practice in standards language, it means, well, here's what you ought to do, but it's not really required. When it's a standard, then the language is such that it's prescriptive, and says you shall and you will versus should and may. And the NFPA, who publishes the National Electric Code, NFPA 70E, which is under the National Electric Code, which is what we talked about earlier for safety, and then NFPA 70B for maintenance. I'm on the committee. Tom Bishop's on the committee from ESA, and others. So it's being converted to a standard so that it can be more definitive on the expectations, and also it's sort of a vision that NFPA has, in that they have this trifecta of standards: a National Electric Code, which is installation standards; NFPA 70E, which is the safety standard for work practices; then NFPA 70B, which is the standard for electrical equipment maintenance. And the reason why they're doing that, at least personal opinion, I think, is that there's a push and a drive under both the NEC and the 70E to apply maintenance and maintenance condition or condition of maintenance back to safety and back to as a requirement, so that, again, you install it under the 70, you do it safely under the 70E, and you maintain it under the 70B. And so there's a correlation there with all of those, so that they can apply maintenance practices back to safety. And so you're going to see that as a standard, as it becomes a standard. You're going to see that more and more in industry, where those maintenance practices will be more requirements than they are suggestions. And so it's being done right now. It'll be out in a couple of years. We just had the first draft meeting. The comments just closed. We're going to have the first draft meeting, and you'll see that change. And so there's going to be a shift in industry to really point to 70B, and that's why Tom Bishop and ESA are very active in that, because we want to make sure that they're getting it right on the motor side, and it's why you get involved in those things. So understand the 70B and get a copy of it if you can. And then I mentioned it before. I'll mention it again, NFPA 70E, the safety standard. That's really important for your workers. And I'll give you this too. If you don't have a copy, you need to get one. But what you should do as well is they have NFPA publishes a document called the NFPA 70 handbook. And so if you get the handbook, because it gives you the standard, but it also gives you narrative on, again, standards are written in such a way that they're a little hard to understand, but they give you a lot of the why behind the reasons behind things. And so that handbook is a great resource for doing a deep dive and understanding kind of the intent of certain sections of the standard. And then the IEEE has many standards and guides that related to rotating machinery, and you should be familiar with those that are applicable to whatever machines you have, and participate in the IEEE conferences. PCIC is a great conference for the Petroleum and Chemical Society. It's going to be in San Antonio in September. Be a live show like this, and it's a great. The chemical plants, refineries, they have a ton of motors, and it's not unusual for a large refinery or chemical plant to have 1,000, 2,000, 3,000 motors. So there's a lot of motor influence in that particular conference, and it's a great hands-on conference. Again, ESA participates quite a bit. San Antonio in September, I would suggest you go down there and just network with folks and learn about all this stuff, right? But great resource for information from the industry. If you haven't thought about it, think about it. And so when you talk about maintenance, how often should we do maintenance? And, what should we do? Well, we've got these codes and standards and all this stuff, and so the answer is pretty simple. It's kind of like Jerry said this morning. It depends. Understanding maintenance and maintenance condition and cycles and timing, it's different for everybody. And so how frequently you should test something, it's not impossible, but there's no magic answer to getting that question. And Jerry had a great slide on preventive and predictive and all the different types of maintenance. But everybody knows this. From the first day that electrical equipment is put in service, it begins to decay and to die. Right? At some point, it's going to be the end of life. Unfortunately, much like us, there's going to be a time when it's all said and done. But there's many things between first day of energization and last day of service that can affect the longevity of that device and that piece of equipment. And so you have to apply those factors to your decision-making process. And so use subject matter experts that understand either the equipment or the conditions, or it could be internal, could be external, and apply those to your thought stream when you're thinking about what should I do with this piece of machinery. And if you do that, then things will be much better. If you don't do that, well, it's kind of like your car, right? If you never maintain your car and never change the oil, well, guess what? You're not going to have it as long as if you did do the maintenance that you're supposed to do. And the manufacturers are a great resource for that. And I have to say this: most of those, or pretty much all of those standards, unless it's a standard that they're built by, like the NETA standards, for example, or even the ESA standards, they default to the manufacturer's recommendation. And so 70B does that as well. It'll default to what the manufacturer says you should do. So always check in with the manufacturer as well and understand what they want you to do to it as well. There's factors, there's influencing factors. You've probably seen this, if you're familiar with 70B, you've probably seen this chart before, but there's many things that affect safety and reliability, and it's things you have to apply. And so as you do those, one of them is how critical is the piece of equipment. This is a big decision-making process as you figure out how am I going to keep this from failing, how am I going to think differently about it. If this is a picture of a generator step-up, a GSU transformer at a power plant, there's a generator on the other side of it, and it's feeding, at 21 kV or so into this transformer. It's stepping up to probably, I think it's 230 kV, maybe 345, 230 kV. So that singular device, that transformer, is very critical to the operation of that plant, because if that transformer goes down, well, then they're out of business, right? So that's very critical. There's a lot of maintenance. There's a lot of testing. There's a lot of online monitoring that happens. And so criticality is a big influence into how often you do something to a machine. And it doesn't have to be a 150 MVA or whatever that is transformer. It could be something as simple as a 5-horsepower motor that provides ventilation from a toxic gas at a semiconductor plant that keeps everybody from dying, because if it goes out, the fab gets full of toxic air and everybody dies. But whatever that is, whatever that critical nature is, that's a big factor into determining how often you should maintain it and how often you should look at it. Also, the current condition of the equipment. Is it old? Does it have tracking? Is it, this has treeing on, this is a bus bar feeding a motor. And so again, it's one of those external factors that you have a medium voltage machine that keeps tripping off, and they say, well, the motor keeps tripping off. Well, maybe it's not the motor, maybe it's the fact that the bus bars are not, the heaters aren't on in the cell, and it's not, you haven't maintained it, and you keep tripping at the leads of the T leads of the motor in the junction box there. Condition of the equipment. Lubrication's a big deal. We talk about lubrication. There's a whole host of, we could have many days of, and there are, about lubrication, proper lubrication, compatibility, all that stuff. I know we deal with that a lot, Calvin, on customers and lubricant. We're always having lubrication issues, right? What's the most common problem we have?
If you look at your chart there on motor failures, the most common failure is bearings, right? And when I go through and I look at motors that come in our shop, it's mixed grease or not enough grease or sometimes too much grease. We were in an outage at a customer site one day, about 2 weeks was the length of the outage. We're finishing up, putting some motors in and doing some final connections and putting coupling covers on, and I'm walking through this mill, checking, making sure everything's done and getting done. And as I'm walking through the end of this mill, I hear choo 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 choo. So it's one of those pneumatic grease guns, right? So I'm walking down and I'm going to where this motor we put in, and as I go down, this noise gets louder, choo 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 choo, right? I'm like, well, somebody's greasing something. So I get down there, and this guy that this company had hired, they just hired like a temp guy. He's sitting up there smoking a cigarette, and he's got this grease gun on this motor that we just installed, right? Just pumping it. It's a DC motor, just pumping it full of grease. Well, his job was to go through this mill and grease the couplings. This guy was looking at every greaser he can find and just pumping it until it oozed out somewhere. So we take the covers off this DC motor, and you could not see the commutator for all the grease that was. I mean, it was up against the plates of this of this motor. So understanding what you're doing, and the type of lubrication, and then the frequency of the intervals as far as changing out oil, like on a sleeve bearing motor. I mean, there's a lot of influencing factors. The environment the machine's in, right? Do I lubricate it as much? If it's in a harsh environment versus inside an air conditioned building where outside it's 110 degrees versus inside it's 72 degrees. So yeah, there's a lot of different factors, and I mean, for me, the number one thing is the guy that's doing the maintenance work understands what he's doing and not pumping a DC motor full of coupling grease.
So going back to what we said earlier, that being qualified it's not only for electrical safety, it's for any task you're doing. This guy was not qualified, right? He didn't know what he was doing, and it wouldn't have been very hard to teach that person what he or she should do relative to lubrication of those gearboxes, right? So here, see these? You lubricate those. So a little bit of time, a little bit of assurance that they're qualified can go a long way to.
I actually think. So at the time, we had an account manager that was over this, that handled this customer. I'm pretty sure he probably paid this guy to pump this motor full of grease.
Well, there is that.
Right? So we could get it back in our shop. But anyway.
Calvin, you weren't supposed to say that out loud.
Yeah. I'm just kidding. We just talked about that a little bit.
Yeah. Don't edit that out. Yeah. No. And then the history, do you maintain the machine well? Do you take care of it? Are you doing what you should do on this? This is a DC motor that was built in 1956. And it gets a lot of maintenance, and it was going very strong for many, many years until it was changed out with some Chinese motors, and we won't talk about that, but what happened there, but it didn't last as long. But maintaining your equipment is key. The history of it's key. Is it a machine that fails all the time? Do you have issues? Are there common issues? Is it misapplied? Do you have a type of machine in an environment that it really shouldn't be in? And so now you're talking to the customer about capital expenditure to spend a little bit of money to get the right kind of machine. Again, that's part of your decision tree. It's part of your failure analysis. It's part of stepping back and don't keep fixing it. Don't keep fixing it. It's important. And then your experience in industry. Do you have people that understand what they're doing? Do your people, do your contractors, do your outside folks, whoever you're using, do they have the experience and the understanding to really, are they qualified? Have they done it before? Those are all important factors. And then what's your philosophy? Again, it's that run to failure, predictive maintenance, understanding, looking down the road, understanding what's going to happen. Hey, we're at the end of life, or we're going to be in a few years, so now let's put the capital money in to plan for, change outs. What is somebody's philosophy? That can be a big factor in how things go. And then the environment. Calvin mentioned it. It's if you have equipment that's in a pressurized room and the conditions, or a motor room where it's clean versus out in the mill where it's dirty, obviously that affects service life, affects reliability, affects failure rates. Encourage and understand and talk to your folks about improving the environment. It may be something as simple as you're out doing maintenance, or you're out on a failure and you're in a room and they never change the filters, and so it creates a lot of dust that shouldn't be there, and so you do something as simple as creating a process of filter change outs, and the machine lasts longer. Works for air conditioners too, by the way, which I just found out a couple weeks ago with my air conditioner at home. Probably ought to maintain those filters a little bit more. keeps them working better. And then how much time do you allow for maintenance? We see this a lot, and I can tell you it's really important for management and people to understand, production's running and you're making a lot of money and all that, and so, okay, we're going to give you 12 hours to do your maintenance, and you really need 24 hours or 36 hours. And so having that dialogue, having that understanding, pleading your case so that you get the time that you need so that you don't rush through and make mistakes, that's an important factor to both understand and prioritize. And again, and this all comes, again, full circle back to understanding what the standards tell you should do, understanding what the industry experience tells you should do, and understanding what the machine requires. Again, when you know better, you do better. And if you got 12 hours, well, then maximize that 12 hours. And maybe you do something in one area and you don't in the other because it's a subjective risk that you take, and just because you're trying to prioritize things. But that time for maintenance is important. And then the manufacturer's recommendation, I mentioned it before. They're going to know, they should know, if they're still around, what their machine requires and what is recommended and support and all that. If they've gone away or don't exist anymore, well, then they've gone away. But there's also people in the industry that can help you with that. And then, so when do you do it? When do you perform maintenance? A great question. Again, I said before, it's something that you really don't have a magic answer for, and there's a lot of guidance out there. There's a few places for guidance. Most of it resides in this room with the subject matter experts that you are, to applying all those factors to it, and then you make subjective decisions based upon what you know about the plant, the people, and all those things that we just talked about. But there are a couple of documents. NETA has some guidance for maintenance time frames, and it's based on criticality and how important is it and time. And so you put that, there's a maintenance matrix that you can apply factors to a time-based thing. And so NETA has that within there, whether it's low, medium, or high reliability, and so you can apply those factors and figure out how often you should do something. Again, if it's critical, if it's a fire pump, that's critical, right? If it's a exhaust fan for the shop, maybe not as critical as an exhaust fan for the restroom, more critical. So apply those factors and it'll help you. The condition, what condition is it in? That's another factor. Is it low, medium, high condition? Those are the categories. You apply condition, you apply reliability, you come up with factors, and then it gives you some guidance on visual mechanical, and visual mechanical electrical. The 70B also has, NFPA 70B has some guidance on maintenance periods and all that, so check out the 70B as well. And then so what does all this mean? So you have to make critical decisions based on actual conditions, and you have to apply sound judgment. So we say that there, and those decisions you make, again, will help you make the right ones. And if you do it safely, and you say, okay, well, that I got it, and that's easy, right? But no, actually, there's one other thing that I'll talk about, and I mentioned it before, and it kind of goes back, it goes back to the 70B, to the 70E, and to where industry is kind of going relative to this topic, and that's condition of maintenance. If you haven't heard that term before, you're going to hear it more. It's getting embedded into the standards now, and that term, it is this. So here's the definition in the 21 edition of 70E. It says, the state of the electrical equipment considering the manufacturer's instructions, manufacturer's recommendations, and applicable industry code standards and recommended practices. So it's the state of the equipment, and you're factoring in all the things that the manufacturer and the industry standards, which is AR100 or the 70B or the NETA's testing standards or the manufacturer's, again, I said manufacturer recommendations. So you're applying that because what they're saying is the electrical worker in the field has to have an understanding of condition of maintenance before they interact with that piece of equipment. And so the standards are pushing us to do that from a safety standpoint. so that we have to, when we walk up to something, we have to, as an electrical worker, we have to understand what condition of maintenance that's in. And so there's words in there, and there's some examples of where it is on the electrical safety program. It's in the arc flash risk assessment, which you have to do before you interact with equipment. And it gives you some, and there's other places in there where it just talks about condition of maintenance. And so you need to think about that and look at that and know whether something has been properly maintained, because there's criteria in there from a safety standpoint that says before you interact with it that's one of the criteria that you have to have. And so understanding that is real important. So I'll point you to that, and I'll say look at that, understand it a little bit better, because it's going to be more and more a part of what we do each and every day. And the other thing that happened is, so when I put this together, I noticed that there wasn't a summary slide, and I always have a summary slide. And so when you put presentation, I don't know if you guys do this, you put presentation together and you have different things you're doing and you have it at the end. And so I deleted the summary slide. So I'll say this in summary. We're getting close to the end. We'll take some questions because we got about 10 minutes left. When electrical equipment fails, you need to think about why it failed. And then you need to put a plan into place to troubleshoot it in a safe and comprehensive manner. Because if you do that, if you have a machine, whether it's a small failure, a big failure, a medium failure, if you think about those processes and you put together a structure to it with your people, and it could be a shop floor failure, a test floor failure, or it could be in an industrial plant, it could be a big power plant, whatever, a commercial building. But if you kind of approach it with that same mindset each time, where you're going to put together, applying some of the ESA rules, on why, and just put that and think about it, it guides you down a path of a more comprehensive analysis, and to figure it out and get to the root cause and try to not let it happen again, change your actions and all that. So it's really, really important to do that. And then as you've done that, and then when you perform maintenance as a qualified worker, so you're doing maintenance on a piece of equipment, and so you're trying to prevent failure from happening. If you're applying maintenance practices and procedures, again, in a comprehensive way, using subject matter experts and industry standards and the ESA standards and all those things, and you do the right thing, well, then you end up with better data and better results. And so it's really important to do that as you go through your maintenance processes. Because if you do all that stuff, you apply the standards, you apply the safety rules, you train your people to do it in such a manner that they understand what they're doing, and they won't pump grease into the bearing. You end up with a more reliable system for sure. And again, I'll say it one more time: use the ESA products for guidance, and you'll have a safer environment for sure. That's what we had for this. It was just, again, the idea was, I'll come back to it, is to hopefully get you to think a little bit more, maybe look into those resources a little bit deeper. I know we have found that our folks out in the field and in the shop, they won't just naturally pick those things up and start reading them. Because why would you read a standard on electrical equipment? But if we highlight to them as they go through their careers and advancement that if you know more, you know better, you do better. I would suggest to do that as just kind of a parting thought there. Is to do that. I suggest you do that. All right, you got anything else, Calvin, before we go?
Just to follow up with that. So talking about before we started this, we were talking to a couple of guys about people, right? Hiring people. It's really hard to find good people. What we've been doing is just bringing temps in and test driving them. And if they show up every day, right, and they want to work, then we start training them, right? So we talk about the AR100. At Shermco, we give access to our employees to the ESA technical manual, the medium to large practices. They've got access to all that stuff. And what I try to tell these guys is, man, if you learn this stuff, you can get a job anywhere in the United States. Because I guarantee you, if I've got a good guy, and let's say that he meets some girl from North Carolina.
Hawaii.
Huh?
Hawaii.
Okay. Meets a girl from another state, right? And she wants to move back home and be with her family. And this guy, we've been training him and showing him how to do the right things. He leaves and he shows this experience. He can get a job anywhere. And so that's what I try to do is encourage our guys, learn this stuff. I'm hoping I'm going to keep him, right? But tell him, man, if you learn these things, your world is open. You can go anywhere and get a job. And so that's one of the things that we try to do is train our guys, encourage our guys. And like Ron says, you walk out in the shop and you say, hey, if you can tell me this, I'll give you $20 or whatever it is. In the shop, we have what we call these hold point processes, right? So when a technician, whether it's a winder, a machinist, or a mechanic, gets to a certain point, what we have is a hold point before you go to this next step, whether it's going to balancing or whatever. Well, one day, I don't do a lot of hold points, but I am a hold point approver for the shop. So one day I'm walking through the shop. We run 2 shifts at Shermco. Second shift machinist says, hey, Calvin, I need to do a hold point. He's turning and undercutting a commutator, right? And I said, okay, so we're going through this hold point process. There's a line of questions. Have you done this step? Have you done this step? And then I asked him, I said, what's the surface finish supposed to be on that commutator? And he goes, huh? I said, the surface finish. Man, I'm not sure, right? So we go to the land where we keep those technical manuals. We look it up. It's in the DC repair manual. I'm not sure the complete title. We find it. We go through. We find out what that surface finish is. Boom, right? And when we've trained that guy on that, now he knows. Now he can talk to the other machinist in no amount of time. Okay. I thought you were showing your phone because I was done. Okay, so yeah. So anyway, that's the biggest thing for me and for us, whether it's in the shop or in the field, is trying to find people, the trained people, and so we've got to train them ourselves, and hopefully they don't leave and go somewhere else. The thing that I find that works best for me is treat others as you would want to be treated yourself, and typically you can retain them. And I think back when I started at Shermco in '90, we didn't have that access to those manuals and that information. And, man, there's a lot of good data out there. I've got a guy that works in our shop right now. He's 38 years old and knows a world of things that I wish I would have known when I was 38. So I encourage y'all to
Great point. Get them excited about the business.
Yeah. Yep.
Any questions? We do have a few minutes if anybody's got any questions.
It seems to me that, thank you first of all for your presentation, it seems to me that a really valuable tool in all of this is benchmarking of the motor, drive, whatever it is, when you first install it, and then benchmarking it during routine maintenance and especially during reinstallation. You'll learn more information from referencing everything back to those benchmarks than probably any other data you can get.
Great point. Great. So the point was that about benchmarking when you first install, benchmarking when you take it out during your maintenance cycle, right? And taking that test data or whatever data you have or performance data, and then monitoring it throughout the life cycle of the machine. Is you got a reference point to go back to and see when that knee of the failure curve starts to occur or whatever. I guess that's kind of the point, right? Is about benchmarking is so important. It's a great point for sure. And oftentimes isn't done very well by the customers, right?
Well, they don't benchmark the right things. They only benchmark the motor. You got to benchmark the driven equipment.
Yep.
You don't take vibration on the motor. You got to take it on driven equipment too.
Yep. Going back to that system comment, benchmark not only the motor but the system, right? Because oftentimes it's a system issue, not necessarily a singular motor issue, right? Great point.
Yeah, and that understanding. So we go out and do PMs on DC motors, and we go in and we inspect the brushes, inspect the commutator, and then we do testing. Right. Well, I had a field service technician. goes out to do this maintenance. He calls me up. He says, "Hey, Calvin, we just got through cleaning this DC motor up, and it's got a low mega reading. It's basically grounded." I said, "Okay, what was it when you started?" Huh? Right? So knowing what it was before you start doing that maintenance on that motor, now you can identify and isolate that DC motor. So that was a learning moment for that young man, because he didn't understand or didn't know that I should have tested this motor before I started doing a PM, because it may have been a poor mega reading when I started. I don't know. And now we're in a predicament because now we've got a grounded motor that just went offline. So things like that, having those baselines and understanding what you're doing can save you a lot of time and money.
Anybody else got a question? Yep.
In a rare case, field guy might see a situation where the manufacturer's recommendation doesn't meet our best practices, industry standards. How would you instruct the service to proceed in a case like that?
Yeah, so I actually flew to China back in 2017. Ron was talking about these large motors that they replaced with these motors from China. And we were sitting in this room with these engineers, and this one gentleman was their bearing expert. And they started talking about bearing alarms, right? And he said, "Yeah, set the alarm at 170. Well, I've been watching these motors in this mill run, and they run about 100 degrees because they're in an air-conditioned drive room, and they don't get hot, right? So I'm thinking, wait a minute, guys. If we set this temperature trip at 170, and these motors normally run at 100, we're going to have a catastrophic failure, because by the time it gets to 170 and it gives you alarm, a lot of things are going to happen." So I said, we probably need to go from 170 down to probably maybe 120, maybe 130 for my alarm. So just understanding the conditions, understanding the motor, and not just going by this is what the manufacturer said. But you've got to talk about, the things that you're doing and why you're doing. So I'm actually protecting the customer and us by, hey, let's drop this alarm down to 120 or 130, because normally it runs at 100. By the time we get to 170, we got some major problems. So just that, the subject matter experts like Ron was talking about, be that subject matter expert and understand the condition and the situation you're in, and work with your customer and work with your team, right? I mean, the luxury that we have now with these mobile devices, I mean, we can do FaceTimes, we can do team meetings. We were doing some troubleshooting in a refinery up in Kansas, and one of our field technicians is walking through the field doing Teams meeting, and we're talking about, hey, look at this, check this out. So when you get into a situation like that, encourage the guys to talk to you and talk to that subject matter expert.
Yeah, and it comes up a lot where you have a manufacturer, customer, service provider difference of opinion. And so ultimately, and it depends on where you're at in the cycle of the machine, right? If it's a warranty issue, well, you tend to, and the manufacturer typically overrides most things. And so that's where, but if you like Calvin said, but if you understand the conditions, all document it all, for one thing, get them to say why it is what it is. And then it just has to be ultimately oftentimes the customers, through, again, subject matter. I'll give you an example that happens a lot on motor case circuit breakers, because NEMA has a thing called NEMA AB4, and they have guidance on instantaneous trip levels on motor case breakers, right? And so you go out in the field and you test motor case breakers, and oftentimes there's a on the time current curve there's a percentage that it's supposed to be within and all that, and so inexperienced testers will go out and test, and they'll fail motor case breakers because they don't match the curve, the trip time of this curve, and they say, well, it tripped outside the curve. Well, AB4, which is the standard that they're manufactured under, has a wider range of acceptable limits, and the time current curves are only there for reference only. They're not actually absolute. And so oftentimes people get caught up with, say, hey, this failed, and especially on new equipment, and the manufacturer will bring out AB4 and say, no, it's within this standard. And so it's understanding what the manufacturing specs say before you stand up and say, yeah, no, the insulation resistance was X, and that's bad. And then you go to a NEMA document or something that says, no, the acceptable level, even though it's bad, because you got 5 machines and you got 100 megohms, 100 megohms, 100 megohms, 2 megohms. Something's wrong with that. And they said, no, it's minimum 1 megawatt or whatever. I'm just using an example. But that process is a great process to go through. Involve the manufacturer, involve the customer, involve the experts, use the standards to reinforce, and then you come up with a decision. Yeah. But it can be a tough battle sometimes, so, and a little precarious, and so just be on your toes and hold your ground, right? And advise the customer, right? You're there because you're the experts. So I know we're out of time, but thank you very much for your time and attendance. We really appreciate it, and we'll see you on the next one. Thanks.
Thank you.